Today I'd like to talk about how myogenesis slash hyperplasia works. Specifically, how do we cultivate the needed stem cells in order to grow new muscle tissue? I focused already quite a bit on the anabolic stages of this process, where the muscle is actually growing, but what's often overlooked is the preparation stage. For any of us that have been training for quite a while, we find that there's a point where we feel like we've just run out of runway, where no matter what we do, no matter what we tweak and fine-tune, we're just not getting the growth that we were previously. One of the reasons for that is, in my estimation, a lack of viable quiescent stem cells in order to grow into new tissue. Now, there's obviously the sarcomeric growing of, hypertrophy, where you're filling your muscles with fluid and nutrients and so forth. But what we're talking about here is myogenesis, the adding of new actual tissue, the myofibers. Here, let's see. Here's the basic stages we're talking about. We have a satellite cell, there's activation, proliferation, which becomes myoblast, differentiation, those become myotubes, and then maturation, which is where those myotubes fuse to the myofiber, the existing muscle tissue. That's what we're trying to achieve here, and that's where real, true tissue lean gains are going to come from throughout your life. The problem is that once you've used up your initial cache of muscle satellite stem cells in your first 6 months of training, your first steroid cycle, your first big peptide cycle, or what have you, where do you go from there? How do you cultivate more? That's what we're going to talk about today. This illustration here shows quiescent satellite cell, and basically following the same process we just showed with the other graphic. But what is quiescent? Quiescent is just a satellite cell that's waiting to be used and woken up. See, as you go along, you can call stem cells into play, but if they don't survive the process, you don't get much growth from it, if any, right? So what we're looking to do is to create very hardy, deep quiescent stem cells and then bring them up through raising our calories and other natural or unnatural means to get them to grow. What I believe we're aiming for is to get muscle satellite stem cells into deep quiescence. And hear me out, here's why. As nutritional hormonal stress circumstances improve, more calories, rest, etc., deep quiescent cells slowly become simply quiescent cells. But these previously deep quiescent cells are actually hardier than other satellite cells. They've been fortified, they've been strengthened, and they're much more likely to survive the process of myogenesis, the proliferation, the myoblast, all those other stages, when they've been fortified like this. First, we've got to cultivate some of these stem cells, and that's not going to happen in a big caloric surplus or on a big cycle. You're going to be growing and you're going to be feeding. There's not going to be the stress that would induce deep quiescence. I've used this study as a reference before. I don't know if it's the same link, but this is fasting induces a highly resilient, deep quiescent state in muscle stem cells via ketone body signaling. Now, what that basically means is when you're fasting, you're in very deep ketosis. The ketone bodies from that ketogenic state actually stimulate a deep quiescent in muscle satellite stem cells. And the highlights are fasting induces a highly resilient deep quiescent state. Deep quiescence is characterized by delayed cell cycle entry but heightened stress resistance. The ketone body, BHB, let's just say that, can directly promote deep quiescence in muscle satellite cells. The effects of BHB are due to its role in HDAC as an HDAC inhibitor and are mediated by P53. If you want to understand what that means, get into the study here. I'm not going to go over every little bit of it, but you get the idea. So, what are some natural ways we can do this? Well, we can do a ketogenic diet. We can take ketone bodies. We can do fasting. Whatever gets those ketone bodies going and stresses your body and makes your body feel like, hey, we have to fortify some of these cells to survive, that's what's causing that deep quiescence. And it happens to work very efficiently through ketosis. Now, it should be noted here that during this deep quiescent state, muscles' stem cells are actually highly resistant to activation. This is not the growing phase. This is the phase of stressing the cells. And here's just a little AI overview on the topic. Muscle satellite cells in deep quiescence refers to a state where muscle stem cells, also known as satellite cells, are in a very inactive and dormant phase, essentially deeply resting and highly resistant to activation. Deep quiescence acts as a protective mechanism, allowing the muscle stem cells to remain viable and ready to regenerate when conditions improve. So, in other words, as I said before, when caloric, stress, hormonal conditions improve, then the anabolic process kicks off. Those stem cells come out of the deep quiescent state and just become very hardy, very strong satellite stem cells. Another way, and this is just my personal theory based on some observations, is training stimulus, training stress itself. See, training stimulus can activate mTOR, which would be more along the anabolic side of things, so protein synthesis, but it also locally in the muscles trained stimulates the production of MGF. Now, MGF, another word or another title for it, among others, is IGF-1EB. So it's just another form of IGF-1, and that's one of the reasons why if you hear somebody talking about overtraining, what may be happening is they're training so much and so often that they're not getting to the place where they're in a rested, well-fed state where they can make that transition out of deep quiescence. They're just constantly stressing those tissues, stressing those muscles. So while they would probably have a lot of build-up deep quiescent cells, they're not giving themselves the opportunity to repair and grow. So maybe that's a definition for overtraining. Maybe that's a mechanism of it. Hard to say, but just an idea. But that said, training itself can stimulate MGF production in the muscle, which, if you think about it, would divert, because we're using growth hormone, IGF-1, as our template for that. So it could possibly divert some of the resources from the more anabolic aspects of those pathways as well. So we're telling our body what to do. When we train, we're stressing. When we're recovering and eating well, we're growing and repairing. While I was getting ready to put this video together, I stumbled across something I didn't know about at all, which is the role of vitamin D in myogenesis. I'll link this in the description as well, but I haven't delved deeply into it yet, but looks to be a very interesting study and worth taking a look at. Now let's take a look at some of the unnatural methods a person can use to stimulate a deep quiescent state in muscle satellite stem cells. One of the methods is to boost your levels of or take exogenous growth hormone. As it says here in this simple AI overview, growth hormone can stimulate the production of mechanogrowth factor, which is a spliced variant of insulin-like growth factor 1, meaning that when GH is present, it can lead to an increase in MGF levels within the body, particularly in muscle tissue where MGF plays a role in muscle repair and regeneration following damage or exercise. Essentially, GH acts as an upstream regulator for MGF expression. So anything that raises GH, that could be growth hormone itself, that could be CJC, ipamorelin, MK677. Obviously, GH itself would probably be the most potent of those combinations, but I've heard you can do good things with MK677 and CJC combination. Briefly, I'll mention ACE-083. Recently, we did a video on that. It looks very promising for localized, deep quiescent state, doing the things we want to do to prepare those stem cells for growth. But the problem is right now, in order to match the amounts used in testing and with getting good results and the studies and stuff, it's not cost effective. It'd be hundreds and hundreds of dollars just to play with it. So not really ready yet on that front, but once the price comes down microgram, milligram for milligram, that'll be something to look into. Now, I don't want to reveal anybody's personal information, but a viewer reached out to me and told me about their experiences with dihexa, and what they explained to me sounded very much like a 10-day lead up to a growth phase. And it sounds very much like what dihexa is supposed to do, which is to prep those stem cells. And what their experience essentially was they used dihexapeptide for 10 days and didn't see anything happen. Didn't feel anything, no difference. That's been my experience with MGF, EGF, anything I've played around with like that on this phase. It's not stimulating. It doesn't feel like anything. You don't get big muscles from it. It just feels like nothing. They said nothing happened. They quit using it. Then over the next couple weeks, if I remember correctly, even though they were on a slight calorie restriction, they grew something like 7 or 8 pounds without making any other changes. And what they described to me sounded very much like the kind of growth that you would get from an Increlex or a slow-release oxytocin during a growth blast phase where you're experiencing the later stages of myogenesis. Again, I don't want to share their personal information, and it's still something I haven't tried. I just haven't got around to it yet, but that's definitely on the list. That sounded very effective, and when I looked into it more, it really made sense scientifically, or at least from what I could find. I've already mentioned MGF, but MGF itself as a peptide to inject, for me, I'm on the fence on this one. Some people say they've used PEG MGF and this sort of thing, and it actually gave them the kind of results we're looking for here. But I'm on the fence. I've never had that kind of experience from any kind of MGF I've tried. I haven't tried any in over a decade, to be fair. But when I did experiment with it, I didn't see the kind of results we might be looking for. That said, I might have had a bad source. I might have had a version of it that just didn't work. Who knows, man? It's been a decade and a half, I would say. So don't let me poo-poo what could be a good, helpful peptide. And that said, that's kind of the end of my list right here. But I know that's not all that's out here. We're talking about stuff that will stimulate the deep quiescent state of muscle satellite stem cells. If you know of something that worked along that pathway or have some insight to add to the conversation, please feel free to correct me. Feel free to add to, take away, whatever you need to in the comments. I want to further this discussion and continue to learn myself. So thank you for your patience and thank you for your participation.